Hello everyone, my name is Ada Jimenez and I will be presenting the topic of water use in agriculture. I will also discuss how much water is used for agricultural farming, which crops take up most of this water, and what the sources of competition for this fresh water are. According to the United States Geological Survey, Earth is about 70% water. Of that water, less than 4% is fresh water. Of that fresh water, about 68% of it is within ice and glaciers, and 30% is in the ground. The surface water that most humans use accounts for 1/10,000th of 1% of Earth's total water. As you can see on the image created by the USGS, the smaller blue ball is a visual representation of the amount of fresh water on Earth. You can see by the image how rare and important this natural vital resource is. Take this into account as you hear how much fresh water is used to help create our other vital resources like our agriculture. Just how much water is used for agricultural growth? A rough estimated 1.899358 times 10 to the 13th power US gallons are used yearly according to the USDA, making agricultural water use a consumer of about 42% of the US fresh ground and surface water. This amount looks like approximately 755.97 million swimming pools or 143 trillion water bottles. To put that into perspective, it's over 18,000 times the total number of plastic water bottles used every year in the United States alone. If you line them up, the bottles would stretch far beyond the Earth's circumference. Globally, 2,600 cubic kilometers of water are withdrawn each year to irrigate crops, representing over two-thirds of all human withdrawals. Most countries globally use about 70% of their fresh water to grow their crops according to the World Bank and Aquastat. Here you can see a map from Aquastat showing the amount of water and the percentage of water usage from each country for irrigation. As you can see, most countries use at least 50% of their fresh water, if not 70%. The crops that are produced the most using this water are crops like maize, rice, wheat, and soybeans. In the US, most crops that are grown are corn, soybeans, hay, orchards, and cotton. These crops help feed most of the world, but they require a lot of water to maintain. Some ways we can help reduce the amount of water consumed by producing these crops are to improve irrigation methods or by modifying the plants to consume less water while they are grown. There is some controversy and apprehension towards the genetic modification of crops. Some people believe that it can have issues with taking out native and natural crops that have existed for thousands of years. Introducing genetically modified plants could harm the environment by creating an invasive species that may not survive other climates in the future. The upsides are that these crops could be more nutritious and consume less water as they are grown. Some examples are drought-tolerant corn and rice fortified with vitamin A. Next, I'll get into the different irrigation methods we're improving to reduce the freshwater waste. In the US, irrigation infrastructure helps harness and use ground surface water more efficiently. Many farms use a mix of surface and groundwater to help irrigate their crops. Some irrigation systems also help generate electricity and recreational water or wildlife habitats. Some of the most common methods used in the US to water crops are gravity and pressurized systems for irrigation. The five most common types of irrigation for crops are surface, sprinkler, drip, underground, and sub-irrigation. The most water-efficient irrigation is the drip irrigation system that waters crops by using the least amount of water needed to directly water the roots of the crops. Rain-fed agriculture makes about 60% of crops around the world, but irrigated crops help produce more food. They allow the roots to intake more water and produce more food. In the future, we can expect most countries to adopt water-saving irrigation methods like underground and drip irrigation. These methods also reduce the rate of salinization in the water when it is replenished into the earth. Although not as common, some farms in urban areas use wastewater from towns to irrigate their crops. This helps fertilize their crops with nutrients like nitrogen, potassium, and phosphorus. The use of wastewater also benefits the water cycle as it reduces dead zones in coastal areas. We'll get into the importance of the water cycle next. Understanding the water cycle is important to understanding how important and rare fresh water is. As I stated before, most of Earth's fresh water, about 30%, comes from groundwater, and less than 1% comes from surface water. Globally, the challenge with sustaining agricultural growth is providing efficient water use, efficient irrigation methods, and finding sustainable sources of water to sustain crop growth. The main concern for most countries is retaining a sustainable source of groundwater to supplement irrigation methods. Methods that help replenish the groundwater cycle are forest and wetland conservation, desalination, managed aquifer recharge, water diversion, and green infrastructure development. The image on the left gives a great visual explanation for the flow of water in the water cycle. First, ocean water evaporates, forming clouds that deposit water through rain or snow onto the ground. Glaciers and rain or snowfall help form the surface water that is less than 1% of Earth's fresh water. The second image explains how groundwater, our main source of fresh water, is deposited onto the Earth. Groundwater also helps supply our Earth's rivers, lakes, wetlands, forests, and ecosystems. Water then returns to the ocean from streams or underwater currents of groundwater. This movement of water creates the water cycle and gives us our fresh water on the Earth. It is also important to understand how groundwater is replenished through the water cycle. As water falls onto the Earth, it will be deposited into an aquifer after being soaked in through the ground. Another source of recharging groundwater is through surface water irrigation, which helps replenish and recharge groundwater. Groundwater can naturally be replenished or recharged in as little as a few days, or it can be a process that takes centuries. Knowing the rates of groundwater replenishment is important when it comes to local freshwater use. If we deplete this resource faster than the Earth can naturally replenish it, some adverse effects are that it can cause droughts in local lakes and ecosystems, create sinkholes, damage the aquifer's ability to retain the same amount of water in the future, and diminish the freshwater quality as it is not purified as well as it normally is. Although crops account for nearly 40% of Earth's groundwater usage, other factors contribute to its depletion as a resource. Other sources of groundwater depletion include oil and gas production, geothermal energy exploitation, land reclamation, urbanization, the food trade, and sea levels. Climate change is expected to change our abundance of groundwater as the permafrost and glaciers are degraded in the future as the climate of the Earth increases. As the sea level rises, groundwater can also increase in coastal areas as flooding occurs, but it would clearly reshape our modern world's infrastructure. Now that you know how rare freshwater is and how we should carefully use it, I'll discuss the various sources of competition that exist for freshwater around the world. As our population continues to rise globally and our countries develop, the demand for freshwater continues to increase as well. Not only do we use most of that water to feed the increasing population, but we also use it in many industries used to sustain the increase in agricultural demand. Some of the highest increases in freshwater demand are in municipal and industrial use. With an increase in infrastructure and plumbing, more humans have access to freshwater, increasing household and commercial use of freshwater. Industrial use of freshwater mostly includes energy generation and manufacturing. Another source of competition for freshwater is its natural environment that needs to sustain freshwater levels in its ecosystems to maintain different populations across our world. This is also known as environmental flow requirements. As humans divert water currents and deplete groundwater that helps sustain our lakes and rivers that also sustain wildlife, we continue to damage ecosystems and our freshwater resources. Some researchers, like Falkenmark and Rockstrom, argue that as humans use more blue water, the more green water is depleted as well. With excessive blue water withdrawals, we can damage our green water levels and lower our water tables that help sustain our environment. Blue water refers to water that is available for humans to withdraw from lakes, rivers, and aquifers. Green water refers to water and soil moisture that is used by ecosystems to include our agricultural systems. In conclusion, we know that around the world, approximately 70% of the world's freshwater is used to irrigate crops. Most of that fresh water comes from groundwater, which is an important and delicate resource that many sources like cities and manufacturing sites compete for. As the increasing demand for freshwater dries up our groundwater supplies, it is important that we keep a watchful eye on our consumption of this vital resource. We can be hopeful that countries and our generation become mindful of how we consume our freshwater, especially our groundwater. It is important to support the development and the use of better irrigation techniques around the world. We should also encourage behaviors that decrease the use of freshwater use in cities and industries that put a strain on this depleting resource. Here is a list of my resources. Thank you for listening.